Hey folks, this next lesson is about velocity. This video is the first of two videos on this topic. This video will cover just definitions and basic explanations, and the next video will cover practice problems. In the world of average velocity, there's actually three things that we're going to need to talk about to build this idea. So we'll get started with average speed. Average speed is a scalar quantity. So a scalar quantity, remember, is something that only has a magnitude. So it's just a number with units. It has no direction associated with it. So average speed is just a number with units. The units are meters per second because average speed is computed by taking the distance traveled divided by the time elapsed. So this is the total distance divided by what we would refer to as the elapsed time. And this is fairly basic information. You probably did this in middle school, maybe even did it in elementary school, I have no idea. But to get the speed that something's going, this is basically telling you on average during an event how fast something was going. It's not super useful in physics, but it's something that you would encounter a lot in everyday life, depending on what technology you use. Chances are good that your car has the ability to tell you data essentially about every trip you take. When you start your car, it starts a timer, and it also keeps track of your average speed over time, how much distance you've traveled. And so anytime you stop your car, it can report out for that trip that you just had what the total number of miles you traveled was, how much time it took, and then it just divides those numbers and calculates your speed. So whether it's your car, or if you are a runner and you have a running app that tells you data, that would include average speed. It tells you how fast you were going on average. It doesn't tell you anything about where you went. That requires vectors, and so that's where we go beyond that. This is a really useful formula, though, because as we'll see later, if an object doesn't change direction, then speed and velocity are almost interchangeable. So keep that one in mind. Next one is average velocity. This is a little bit more complicated because it's a vector. Vectors have direction associated with them, and it's computed in a similar way, so it's also in meters per second. So average velocity, the symbol would be v average. An alternative symbol for average velocity is the symbol for velocity with a horizontal line above it. My handwriting's not that great, so I tend to not use that one because it looks really confusing, so I'll put v average after that. The way that you would calculate average velocity is you would imagine that you found the location of an object, and at that moment you started a stopwatch. And then after a certain amount of time you located the object's position, and at that moment you stopped your stopwatch. So all of this is divided into two portions here. These two pieces of data are your initial conditions. Now, what's special about the initial conditions for time is that this variable t0 or t0, that's when the time equals 0. Usually. It doesn't have to be, but it's very often that case. And then the symbols t and x, these are your final position and time. So the numerator is actually a lot more important. You have to know the initial and the final positions. The t and the t0, you just have to know how much time has passed. So if you're using a stopwatch, it's really easy. If you're looking at a data table, that's when the denominator becomes more important. All told, what this formula really tells you is that the average velocity of something is the displacement divided by the elapsed time. So this displacement over the elapsed time. And you'll start to see kind of the laziness of notation show up in physics pretty quickly, because up here we had t as elapsed time, and down here we have delta t as elapsed time. And so that's basically interchangeable. It doesn't matter which one you're looking at. In physics, it's important to know how much time something took and not when it happened. Okay, so the last concept is instantaneous velocity. This one will probably have to wait for the most part until the next lesson because of how it's defined. If you are in pre-calculus or calculus right now, you will at some point learn about limits. If you're not in those classes, don't worry about it. But instantaneous is a word that means like right at a specific moment. And so if you define one moment in time, we need to measure or calculate the velocity of something. So it's how fast something's going and in what direction at a single moment in time. And the way that we notate this is with this limit notation. So the instantaneous velocity is the limit as the time elapsed goes to 0 of the displacement divided by the time elapsed. You don't really need to know much about that equation because you're not going to use that equation in this course anyway. What you do need to know is that the smaller you make this time interval, the more accurate your data will be for calculating the velocity at a specific moment. So you can think of it as like how quickly can you press a stopwatch and how accurately can you measure position. There's a literal physical limit to how accurate a person can be when measuring, when taking data. But if we have other tools available to us like calculus or a graph even, then we can use our little tricks to make this time elapsed really small. So really what you need to know about instantaneous velocity is that it is the velocity at a specific moment in time as if no time has passed. So that's the only time we need to know like when something happens. So more on this later. The real like star of the show today is average velocity. Okay, 2 last facts before the end of the video. This word magnitude is going to pop up a lot. Every vector has a magnitude, and this is a special case where the magnitude of the instantaneous velocity is also known as the instantaneous speed. So the magnitude of an object's velocity is its speed. If you take the direction out of the velocity, you're left with the speed. And the last piece of information is that after this lesson, we're really not going to use the word instantaneous anymore. If we say velocity or speed, we're implying it's instantaneous, whereas we would have to say the word average to mean average. Okay, so that's it. Next video, we're going to do some practice problems.